Okay, welcome back to Algebra. We're in Chapter 7.2, Solving Linear Systems by Substitution today. And yesterday we graphed to solve systems, so we know that the solution of a system is where usually the two lines of the system intersect. That point is the solution for the system. So today we're going to learn a new way of solving systems, and that is by substitution. So the first equation, y equals 2x minus 3. So I could call myself y, or I could call myself 2x minus 3, because those two things have the same value. They're equal. So we're going to take the 2x minus 3, which is the same as y, and we are going to substitute that expression for y in the second equation. So we will write the second equation, but where we would have written y before, we're going to put what y equals, which is 2x minus 3. And you can now see that the new equation has just one variable. That variable is is x. So we're going to solve for x. We will distribute the 3, 6x minus 9. We'll combine like terms. So we know that when you don't see a coefficient, the coefficient is is 1. 1x plus 6x is 7x. Next step, we're going to add 9 to both sides. Again, you can pause the video and come back and check your work. And now to finish it, we divide both sides by 7. So x equals 2. Now we know that the solution of a system is a point, right? The point where the lines intersect. And that point would make this equation true and this equation true, both equations of the system. So we have to find the other coordinate to that point. We know part of it, x equals 2. We now need to find the y. So one way to do that is to sub what we just found, 2, in for x, back into the first equation. And notice the first equation has y isolated. We've already got that solved for us. So we're going to plug 2 in for x, and we end up with 4 minus 3, so y will equal 1. So we now have both coordinates for the point. So just as we did yesterday, we're going to want to check to make sure that we have the solution for the system. And how did we do that? We took that solution and we tested it in both equations, right? So I'm just going to use a different color. Don't forget x comes before y, right? So y is 1. I'm going to do it just above. 1. Does it equal x is 2? 2 times 2 minus 3. And yes, 4 minus 3 is 1, so this is true. Now on this second equation, we would say, is 2 plus 3 times 1 equal to 5? Yes, that is true. So we know that this solution is true. Okay? So that's what we're doing today, solving by substitution, which I hope is faster than graphing both equations. Moving on to the next sample. See if you can pause the video, try this, and then come back and see if you agree. Okay, so we already have this equation stating that y equals this entire expression, 2x plus 5. So we're going to sub 2x plus 5 in for y. Now this time, y has a coefficient 1, right? So if I was to distribute the 1 to each term in this group, I would just have 2x plus 5. So we may not even need to show parentheses here. So we combine these terms to get 5x plus 5 equals 10. Subtract 5. I'm sure you ended up coming down to the same value we get here, which is x equals 1. So remember, the solution is an ordered pair, so we must find the second coordinate of that pair by subbing back into the other equation. So we're going to take that 1 and we're going to plug it in where we saw x, right? And we end up with y equals 2 plus 5, or y equals 7. Good. So again, we want to check to make sure that both of these lines cross through this point, right? And we do that by subbing the point into each of those equations. So let's say 7 is the y. Does it equal 2 times 1 plus 5? Yep. How about 3 times 1 plus 7? Does that equal 10? Yep. And so we know we have the solution for the system. So can we make this more fun? Oh yes, we always can. So in this system of equations, it's a little more complicated, right? Because, what do you see? Yeah, there's no variable by itself. We need to solve for a variable. Now, often students think we need to solve for, guess which variable? Yeah, y. And we could do that. We could solve for y. But when we see, let's look at this equation. When we see x has a beautiful positive 1 in front of it, we could just move this y to the other side and have x isolated, right? And how would we do that? Yeah, we would add y to both sides. So we end up with x plus 0, so x equals 3 plus y, right? So we need to stretch our thinking, and we can see that sometimes we might solve for x rather than y. Okay, so we're going to take this whole expression, 3 plus y, and we're going to sub. I encourage you to draw arrows. Students who do that are always successful. Students who choose not to do that are sometimes successful, but more often they're the students with problems later. They forget the strategy. So instead of saying x, we're going to say 3 plus y, because that's equal to x. So 3 plus y, and then bring down the rest of the equation. Plus 2y equals negative 6. Okay, so we know this y has a coefficient of 1, right? So 1y plus 2y is 3y. And so now we're going to solve. So again, pause the video, solve, see if you can find that solution and come back. Okay, so I'm sure you subtracted by 3 on both sides. 3y equaled negative 9. And then when you divide by 3 on both sides, y equals negative 3. Okay, so now we have the y coordinate, so carefully place that in the y coordinate for your solution. And then, yes, draw that arrow, really leads to success, because substitution is always 2 subs, right? We're going to sub it in, and we're going to sub it into this revised equation where x is already isolated. Okay, so 3 plus what we found, negative 3, which we can see equals 0. So we place that in our solution, and let's go ahead and check and make sure that this makes both equations true, right? So if I plug it in, I have 0 minus a negative 3. Does that equal 3? We can add the opposite. Yep, that's true. And 0 plus 2 times negative 3. Does that equal negative 6? And we see, yes, it does. Okay, so let's try one final sample like that. And pause the video, try it, and come back and walk through when you're ready. Okay, so hopefully you identified that the first equation has a variable with a coefficient of 1. So this is the equation where I would isolate the y. And we do that by subtracting 3x from both sides. So y equals negative 3x minus 7. Okay, so that entire expression can be subbed for y, right? So negative 2x plus 4 times the quantity negative 3x minus 7 equals 0. And by doing this, we now have only x's. Yay, we can solve. So we distribute negative 2x plus negative 12x minus 28 equals 0. Together we combine like terms. Negative 14x minus 28 equals 0. Add 28. And then what are we going to do? Yep, divide by negative 14. So x equals negative 2. Okay, so now what will we do? Yep, we're going to do that second. It's a double sub. So we sub back into the revised equation here, where y is isolated. That's what we're trying to find, right? We need the y. So put that negative 2 in for x, And you can see we end up with 6 minus 7. What is that? -1. Yeah. Okay, so we think our solution is -2, -1. So we test it. -2, -1. Does that equal -7? -6 minus one more. Yeah. And over here we have -2 times -2, which is 4. And 4 times -1, which is -4. 4 plus -4 does equal 0. Whoops, sorry. So there is my check. I don't know if you saw that. And here is the solution. Okay, so our final point today is just to sum this up. How did we do this? Put this into process. So how do we solve linear systems by substitution? You know, being able to explain the process is the higher cognitive ability. So the first thing we did, like let's look at number 2 here. The first thing we did was we had to solve for x, right? You have to solve for x or solve for y. So we're going to solve for one variable, which, remember our word isolate, right? A variable. And then we have an expression like this, x equals 3 plus y. Okay, so that's our first step. Next step is we took that expression for x and we substituted it for x in the second equation. So we take the expression from step 1, substitute it into the second equation to solve for the other variable, right? So we were solving for y in that case. So we took the expression for x, plugged it in, and solved for y. That's what that means. Okay, after that, we found y. And feel free to pause the video if you need to, right? And then we subbed it back, and we subbed it into the revised equation, didn't we? We did that so that we could easily find x. So our final step is to substitute the value we found in step 2 into the revised equation from step 1, and we got the other coordinate. So we have the whole x, y. And then, of course, don't forget, always check solution in both equations, just like we did when graphing systems yesterday. Okay? So you can go check out your assignment posted at School Speak, and have a wonderful day.